Hey guys, welcome back to a tutorial in the series on game logic where we are creating Tetris within Minecraft. And this is kind of like the final stretch of this series where we're trying to figure out a way to actually clear the Tetris rows once we place our blocks. Because if you've tested out the program as we've had it so far, it doesn't actually clear the rows. You can place blocks all you want, but you might even end up with like a cool setup where you have, an I block going in and where you're like, yeah, it should clear all the rows, but it doesn't clear the rows yet. So we need to build that in still. And it's actually a very, very tough problem. Okay, and what I've done is in this video, what we're going to do is just introduce a lot of the problems we're going to have to solve as smaller bits for the whole overarching problem. And that's something you'll run into a lot in programming actually. You'll have like an idea and it sounds simple. Well, we just want the rows to clear when we place blocks. But really, there's a lot of stuff involved in it, a lot of problems that are involved in it. All right? And I've made this diagram so that I can, as I'm asking you these questions, we can look at this and sort of play with this and see how things should work out. Okay, so first question. Um, what is clearing a row even? Well, clearing a row is pretty easy, I think. It would just involve, I'm just imagining um, having a drone that would just go across each row and place air. Simple as that. Okay. And um, by the way, in all these questions, essentially what we're trying to do is we're trying to think in code. We're trying to think, well, this is the high level thing that we need to do. This is the in English, in plain English, this is what we need to do. But in code, what is that going to look like even, right? So clearing a row would look like, having a drone place air, moving over, place air, moving over, placing air. Cool. So we can check that for now. We can revisit that in the actual code later. Now, how do we know when to clear a row? That's kind of an interesting question. So we probably should be able, we should I'm imagining that we would ask this question, is a row clear? And then we would clear the row. Sort of like we ask the question, is a move clear? And then if the move is clear, then we move our block. Stuff that we handled in the previous videos. This is going to be something kind of similar where we're going to be asking, is it all right if we clear a row? And then we're going to actually clear the row. So, but what does that question, what does that little process look like? Well, in Tetris, if you don't understand the rules yet, row clear is when you have solid blocks that go all the way from the left side to the right side. So in this instance, let's point out the rows that need to be cleared. There's one, and there's actually two others. Okay. Okay, and I know these shapes aren't actually Tetris blocks, but they're crude versions of what you might end up with as you're playing the Tetris game, right? So this is just represents like a single block. So this row would need to be cleared, this row would need to be cleared, and this row would need to be cleared, assuming this is the block that we just placed. So we're assuming that this is the target block, and we should change the color there just to show this is the one that we just placed. So therefore, and let's even change these to maybe this color to represent there. That's a lot better, a lot more viewable. So, okay, so these two rows right here need to be cleared, and then this bottom row would need to be cleared. Okay, because they all have not air on them. So looks like that's how we know when to clear a row, is if we had a scan drone or a drone that we can call scan drone. If we had that drone move across, and as it's moving across, it's testing the material at each location, to see if it's air. If it's air, then we know immediately that this row should not be cleared. If it's not air, we're going to continue to scan until we get to the very end. And if we get to the very end, then we know that that row should be cleared, right? So in this row, we would get close to the end. It would hit air here, and then we would have to return from maybe our little function that we'll write that says is row clear, or is row to be cleared, something like that. Okay, so that's how we'll do that, and we'll revisit this stuff in the code. I'm just skimming over the questions that we need to ask and sort of how we need to think in the code, in terms of code. Okay, now, how do we move other blocks down? That's a pretty tough problem. So let's say this whole thing progresses. What we would end up with is, okay, so this is what we would end up with here. So the question is, once these two rows are cleared, this bottom row is cleared, is how do we move these blocks downward? How do we move these things down? Well, I could imagine that in that we would have, well, our scan drone, and we would store the material at this location, and then we would place air at this location, and then we would move our scan drone down for however far we wanted to move this block chunk down, and then we would place that material that was there. So then we would end up with air here, and then the new material would be down here. So ultimately, we would do it by the row. So we would move this entire row down block by block, and we would end up with having the blocks down like this, right? So, and that's just for one row. How do we just move one row down? So that is that question. All right. Now, big problem here is how do we deal with multiple row clears? So I'm imagining that maybe the function that we have that moves blocks down, we allow the parameter to be passed in, allow an input to be passed to that function that specifies how far down you want to move a row. This way, we can move down 1 or we can move down 2. Like this one would need to be moved down. Okay? So that's how we would deal with that at a very, very high level still. I understand it's not super detailed yet, but we'll get there. Okay, now how do we deal with spaced row clears? This is the really tough problem with this. All right, so this is spaced, meaning there's this chunk right here of blocks, and then there's this chunk of blocks that's up here. Okay, and so this means we actually would want to move this one down 1. Okay, and then this one up here, we would end up wanting to move down 3. Right? But how do we know we need to move it down 3? It kind of looks like we'd need to move it down 2 at first, right? So the way that we're going to actually do this is sort of consistent with a lot of algorithms that are designed out there. So in this case, what we would do is we would take care of this operation first. So we would take care of this movement first. That moves these down too, because then we only need to worry about one thing at a time. So we move that row down 2, and then we count this entire chunk of blocks as one chunk, and we move this down 1. That simplifies it so much. Okay, so and then we end up with exactly what we should end up with at the end of that block placement. Okay, so and then one of the last questions here is how do we know when no more row clears need to be done? That one's pretty easy. So logically we could say that if we run into a row that is all air, if a row is all air, then we need not proceed and try to scan more, because since each block in Tetris has to be attached to a face, so every block in Tetris is attached to a face. Kind of hard to explain logically, but basically if you run into a row that is all air, you know that there's not going to be any more blocks that are above that. so we could stop scanning, right? Because we couldn't end up placing a block, like a new block. Let's say this is our game board. I've had the desire to prove this to you guys. So, um, there's no possible way to place a new block on here and have there be any sort of air that is between the top portions of this eye block and the bottom portions of this eye block. There's no possible way. If you rotated it this way, there's air right here, right there, but it's not an entire row of air, notice. So if we run into a row that's completely air, then we know we can stop scanning and looking for row clears. Okay? And by the way, one hard-coded way to tell is if we just scan the entire board every time, the entire 20 height of the board. But you don't really have to. It's not really any more difficult to program one more little function that tests if the row is air and just aborts the check. So it enhances our. It's going to enhance our efficiency a little bit, and with not that much extra work. So we're going to do that. Now, one of the last things here is what kinds of data do we need for the algorithm? Um, that is actually a pretty tough problem in itself. Figuring out, once you know kind of at a high level what you need to do, figuring out the actual variables that you need is going to be kind of tough. And I think we should probably cover that in the next video. Yeah, I think that's what we'll do. So thanks for watching, guys, and in the next one we will cover the pieces of data we'll need for this algorithm.